Hey, good day everyone, welcome back. So today we'll be doing a noise terrain generation using parts. So in this we'll make a grid of parts and then we'll use the noise so noise is just like this smooth transition between high and low points. We'll use noise to make some terrain generation. So it's going to be pretty cool, and since it's pretty time consuming, I'll just get straight into it. You only need one script for this, will just be a server script in the server script service. I'm going to call this generation, and this is pretty much where all your parts are going to be made and are positioned. So first, I want the noise function, so math.noise, and then I want to create a grid. So before I do that, I want to I personally I'm going to create a part and then use this one part to generate the grid. So that way I can customize this part and the grid will still be the same. So like if I want it 2 by 2 by 2, I can have the grid this size. Do make sure that one's 1. Let me make that 15. So I want cast shadow off for the moment. I'm going to just color all these white. Make sure anchored's true, can collide's true. Other properties up to you, but this will be my block, and I will be making a grid out of these. So to generate a grid, we want a certain X amount of grids. So horizontally, how many grid blocks do we want? Then we also want grid blocks along the Z-axis, and then we can start crossing them over. So if I can do it in here, we have like block 1, 2, 3, 4, 5, 6. So those are blocks going across. But we also have blocks going 1, 2, 3, 4. Actually no, 5, 6. So we have 6 blocks going that way, 6 blocks going down, and then we'll start filling it in here with blocks. So they'll be joined together, but just trying to visualize it here. Yeah, pretty much this is what it is. And then there'll be blocks going like that, like so. So we're making this sort of system. We'll have the X mount, so we'll do that now. So 4x equals, I'm going to start negative first, so this will determine the position of it. So this will make it so 30 blocks from the left of 0 and 30 blocks from the right of 0 by doing this. From minus 30 to 30. So that's 60 blocks altogether. And then for the Z, I want the same. So starting from the minus Z axis, and then going to the positive Z axis. So that's 4x equals minus 30 to 30, and then 4z equals minus 30 to 30. You can determine how many blocks it will be by doing a print 60 times 60. So that's 3600 blocks we're making here. So that's the area of the stuff in there. And if you want, you can have more than one block on along the y-axis. So like you can have a surface block and then all the blocks underneath, but that's up to you. So now that we've got this, we want to set a new block's position to where it's supposed to be on the grid. So we do local new block. I want to clone this normal block that we've got here. So let me grab that. So local base block equals script wait for child block. New block equals base block clone. New block dot position equals vector3 dot new x and then the y, which I'll just make 10, and z. And then you also want to set the parent to workspace or terrain. I'm going to personally set it to terrain. So local terrain equals workspace with child terrain. Now if we try this and we load up the game, we should see a grid. There we go, and if we hover over it, we can see they're all individual parts. Now I do want to make these blocks move based on noise, for example. So the noise will determine what are higher points and low points, and like it will smoothly transition to between them. If you don't want to read on noise, I'll try and include an article below, just like a simple overview. But yeah, otherwise you might have to go find a YouTube video on it. The coding train is a good guy to check out. He does a simulation in another language or another program called processing. I watched it. It was pretty fun to watch, and yeah, you can check that out. Next we will do a we actually need to calculate all the noises. But before I do that, I want to put all these blocks into a table so I can loop through them and get the noise depending on where the position is on the noise map. So local blocks equals a table. I want to do table.insert blocks, new table. I want the block there. I want the X position and the Z position. Now, before I continue, I do want to make sure that this supports large. Like if I show you in here, you may notice that they're crossing over a little bit. So I want to make sure that the block size matches with like the scale of the grid. So like if I do local block size equals base block dot size dot x. Since this is a block, all sides are equal, so then I can use this to put it in the correct position. So if I do that, they'll be in the right spot. And then I also want to do them there. Now to help this speed up, I'm going to actually calculate this above here. So local x spot z spot equals x block size x times block size, z times block size. So then I can do x spot, z spot, x spot, like that. Now that I've got that, we have all of them inside this grid here, and we can loop through them all and get their position where they're meant to be. So if I do for underscore table, well, not table, for underscore block table, actually, I want to do for index equals 1 number of blocks do, because this is much faster than in pairs. So this one's about speed at the moment, but for easier management and all that, you can use in pairs and just get the table value. So local block table equals blocks index. So this, so you can either do it the way that I'm doing, like this, or you can use for underscore block table in pairs blocks do. So you can do it my way. So that's code there, or you can do that. So this is up to you. This one is faster though, even though it looks bulkier. So now that we've got the block spot, we want to actually get a seed. So the seed will determine what the map looks like. So what I can do is just do local seed equals math.random. So like that, they'll give me like a random decimal. And then in the noise, it takes in a, so we actually, before we do that, we want to make it a variable. So local y spot equals noise. We want to put the seed in, and then we want to put the x spot and the z spot. So there'll be blocks table, block table 1. Oh no, sorry, block table 2 and block table 3. As block table 1 is the part. There is an easier way for us to manage this, so we can just do local part x spot z spot equals, I don't know how efficient unpack is, but if you do speed test it, just getting the index themselves would be probably easier. So like block table 1, 2, and 3. I'll keep it like this though for the moment. So I'm going to go back here. Y spot equals noise seed, comma x spot, comma z spot. So that gets its position on the noise map. And then I want to set the parts position to that y spot. Well, set the parts position to the no, set the parts y to the y spot. So we still want to keep the same position, we just want the different y. So part position equals vector3.new x spot, and then the y spot, and then the z spot. So now we've got all the spots, and this should work. Another thing to note is that this noise map is really small. So at the moment you can see how it's working. It's going up, down, yep. but there's not moving that much because the scale of it is really small. It's between -1 and 1, I believe. So to help this, we will multiply it by a amplitude. So this amplitude determines how scaled it is, which I think I just said before. So I'm going to make a variable for that, amplitude. And if we try it again, we can see that, yes, it works, but it's pretty different at the moment. So the reason why it's so different is because it's choppy. It's going from one position to the next, but they're really uneven. So what we want to do is smooth that out. So what we can do with this is create a noise grid scale, and this will be I want it to be larger than the block size. No, sorry. I want it. So how do I want it? I want it to be a decimal so that it's really smooth as it goes from one spot to another. So if I make the noise grid scale to like 10 and then do export divide by noise scale grid and do it that way, it changes this export. Oh wait, no, sorry, wrong spot. In this noise here, we want export divided by noise grid scale, and the white. Did I do it? No, I did that right way. So on the export divide by the noise grid scale, and then zspot divide by the noise grid scale. So that way it becomes a little bit smaller, and then it will smoothly transition between So instead of like jumping, it would be more smooth like so. So that was a high point, and then that was a little bit going towards the next point, which it got there. So now if we have a look, we can see that it generated a little bit of a map. What we can also do is make it a little bit less smooth and a little bit more amplified. And then you can see that you can get different types of it. So this one's more like a little mountain range sort of thing. But you can smooth it out even more. So by increasing this one, and then also increasing this one, you make it smoothly transition between a bunch, and then you've got it slowly yeah, so just by looking at it, you can say, okay, so this is more like a hilly sort of area because it's not jumping as much. Oh, you can still go smoother though, and you can do like, yeah, you can go very smooth. So like that. That's pretty much like a map thing now. And then if you go ahead and just like chuck it to 100, then chuck this up to like 100 or 50, you'll see that you get some very tall mountains. As yeah, the amplitude's really high, but it's smoothly transitioning between points. And yeah, that's pretty much all this is, just noise generation and placing it on a grid. So I hope you enjoyed.